All right. Let me see. All right, recording now. So the intersection is common to both A and B. Example 1 asks us to find the intersection of set A and set B. You can call it whatever you want because they didn't label it. This set has the numbers or the elements 2, 4, 6, and 8. This set has 3, 4, 5, and 6. So if we are trying to find the intersection, good, then we only want the numbers or the elements of the set that are common to the two sets. Is
4.
So it's going to be a small group. Is that all right?
4 and 6 are common.
4 and 6 are common. Very good. 4 is in both groups and 6 is in both groups. So the intersection of, if you called this A and B, is 4 and 6. Good. All right. So here is an example of an intersection. X plus 4 is greater than 0 and 4x is greater than 0. Okay, so we're going to solve for any number, any solutions that are true for both of these at the same time. Okay, x plus 4 is greater than 0. So we're going to solve for this. We're going to subtract 4 from both sides. X is greater than -4. We're going to graph that one. So here's -4. X is greater than -4. That will go up towards 0 and the positive numbers. And it does not include -4. So it's going to be an open parenthesis symbol. Good. All right. That is not our answer because we also need to find both. So it's both everything greater than -4 and for this one, I just need to divide both sides by 4. Don't be scared that this is a 0. Treat it as 0 like any other number in this case. 4x divided by 4 leaves us with x. We don't need to flip this sign because this is not a -4. So we still say x is greater than 0 divided by 4 is still 0. Good. So they're asking for the intersection of, so common to both, x greater than -4 and x greater than 0. Let's graph x is greater than 0. Here's 0. Again, we're going in the positive direction. And again, it's not including, so it's open parentheses. Good. So the intersection, just like here, 4 and 6 had to be in both groups for it to be part of the intersection. When you have graphs, the intersections are, I said, is or are the values that are within the shaded area. Oops, sorry. Never look up at what I'm doing. Of both number lines. Okay, so if I put these both on one number line, now I have to put -4 over here, 0 over here. I'm going to give them two different colors. So -4 looked like this. 0 looked like this, right? So I just transferred it down here. They are within the shaded area of both number lines. It cannot be anything over here. Think about these as two colors that if they blended made a beautiful third color together, right? So if you put the purple and the green together, that's your answer for intersection. Good. You know it's intersection because it has and rather than or. Good. So the graph of the solution is only from 0. That's the only time that they overlap fully, from 0 to infinity. So if I was to put that in interval notation, I would open the parentheses, put 0, put infinity, close the parentheses. You do not include -4 because -4 doesn't include all of the answers of this side. Oh, good job. How do I know when to use a parentheses and when to use a bracket? Very good question. All right. So, oh, I have it right here. Okay. This one's called set notation. This one's called interval notation. Okay. Set notation is just when you're making a list. Well, the list is not set notation, but it's the same brackets, x such that x is less than a. Good. Less than gives you a parentheses. Greater than, oh, sorry. Well, let's start at the graph. Less than gives you a parentheses. Greater than gives you a parentheses. If you have this or equal to, that's when you get the bracket. Good. The bracket means it includes that number. It could be A, it could be A, or it could be less than A, right? Here, it cannot be A. A is not included. It must be less than A. If A was the number 5, it can't be 5. It can be 4.99 infinity, but it cannot be 5. Here, it can be 5. That would be okay. Here, it cannot be. So use a parentheses when it's not included. Good. So graph it first. It does not include A, so graph the, no problem. Graph the parentheses, and then when you're writing interval notation, just include whatever you started with, okay? So very important also to note is infinity will never have this. Sorry, that has to be negative infinity. So if it's going on forever, you have to include the infinity brackets on one end, but never with those brackets, because those brackets imply it includes that number, right? And infinity doesn't have an end that you can include. So infinity and negative infinity automatically get parentheses. Okay? So when you're going from your set notation to your graph, use this, use your symbol to decide whether it's a parentheses or a bracket, and then to write interval notation, start reading it from left to right. So if on the left, all you hit is an arrow, that arrow means it's going towards negative infinity. So start at negative infinity, go to wherever your graph stops, put whatever symbol you put on your graph. Good. However, here it's going greater than A. So if you're reading it from left to right, like you're reading an English sentence, you're going to hit a parentheses first. So you open your parentheses, put the number you started with. It goes forever. It never ends. Write positive infinity, close the parentheses. Good. So here, same as this, right? Except that it includes A, so you have your brackets. Start with a bracket, go to positive infinity. Here, if x is, this can be written as x is greater than A, right? So you start at A with a bracket, or sorry, with parentheses because it doesn't include A. Go that way. It also includes x is less than B. So that means on this side, you have a parentheses and you're going this way, but it only stays between A and B. Good. Here, these are brackets because of the equal sign. And you might see something like this. One side will have a parentheses, one side will have a bracket. Good question. Definitely worth going over because that's how people fail the test. And you don't want to fail that way, right? You don't want to miss a question because of a bracket versus a parenthesis. You can definitely put that on a note card if you would like. All right. Remember, these are compound, and for a compound inequality, you want to end with x in the middle alone. Of course. Just appreciate anyone asking questions because I know people have questions. It's good to know where we're all at as much as possible. So we want x in the middle alone. There's going to be a term on this side and a term on this side. Just like here, if we had x plus 5 is less than 10, to solve this, I would subtract 5, right? Anything I do to this side, I have to do to this side. X is greater than 5, right? Here, because we have two inequality symbols, we are going to, anything we do to the middle, we're going to do to this side and to this side, okay? So it's like you have an extra side to do each step to. Not the first step, not the distributing of the 4, but anything you do to get x alone, you're going to do to the left and to the right. Rewrite it. 0 less than or equal to 4 times 5 minus x, which is less than 8. All right, let's distribute the 4. 0 is less than or equal to 4 times 5 is 20. 4 times negative x is minus 4x. Notice I didn't do anything to left or right because I'm just distributing the 4 within the parentheses. Now the parentheses are gone. The 4 and 5 became 20. The 4 and negative x became negative 4x. All right, now I'm going to start moving things so that x is in the middle alone. This is a positive 20, so I'm going to subtract 20 from the middle. I'm going to subtract 20 from the left, and I'm going to subtract 20 from the right. 0 minus 20 is a negative 20. That's gone. I have negative 4x. 8 minus 20, remember, you can take the bigger number, subtract the smaller number. 20 minus 8, 12. But it was a negative 20 and a positive 8, so it's minus 12. Stop me if something doesn't make sense. Like if I forgot the sign. Good. So I still have 3 sides, luckily. Now, wow, we really started with a hard compound inequality. We're dividing by negative 4. Remember last week, that if you divide by a negative, it's okay if this is negative, you don't need to do anything. But if this number that you divide everything by is a negative, that means you need to flip all your signs. So before I even figure out what those numbers are, I'm going to flip both of those signs because I'm dividing by a negative 4. Negative 20 divided by negative 4, negatives divided by a negative is a positive. 20 divided by 4 is 5, right? Negative 20 divided by negative 4 is positive 5. Here, I just get to keep my x. Negative 12 divided by negative 4 is a positive 3. Good? All right. So remember, this was changed from that because of that negative 4. This was changed from that because of that negative 4. The negative sign caused us to change our inequality signs. Now we just need to graph this. So set notation would be x such that x is greater than 3 and less than or equal to 5. If I read that, x is greater than 3, x is less than or equal to 5, it's kind of like because I flip those signs, my terms are backwards, right? If I were to graph this, three's over here and five's over here. Right? So once I flip my signs like this, I like to rewrite it so it's the way I usually see them. And there's nothing wrong with that. As long as you keep, I move the 3 over here, so I change the sign. Like I put the mirror image up, right? Because it's easier to see that it's between a +3 and a +5 for me. Good. So that was x such that x is less than or equal to 5 and greater than 3. X such that x is greater than 3, less than or equal to 5. Good. So the way I would graph that is at 3, we're going to go greater than 3, right? Not include 3. We're going to go less than 5, but we're going to include 5. So, and you can do it right on top of each one, right on top of the other, right? So in the end, we start at 3, we end at 5. So my interval notation will be parentheses, open parentheses 3, go to 5, close with a bracket because the 5 had an equals to. That was a hard one to start. Hard, difficult first example. All right.
Can you
Oh.
do another one of those
Yes,
by
I
any
will.
chance? Thank
Of
you.
course. Let me see if I can. Is this ours? Yeah, here's ours. All right, I'll do one from. Here is -2 is less than x, x is less than 4. So this is from the homework. You might get different numbers, but here's a question from the homework. So x is, I'll write that down over here. We need to start with an easier one. -2 is less than x is less than 4. And then let's pick -9 is less than or equal to 2x minus 7, which is less than or equal to 17. Good. So we'll do those two examples from
Thank you.
no problem. Thanks for asking. All right, so here's an easy one, right? Or here's a simpler one than the ones we were looking at. You can rewrite this as x is greater than -2, x is less than 4, right? Just make sure you have fluency with less than, greater than, less than or equal to, greater than or equal to. Now we're going to graph it. Even if they don't ask you to graph it, it helps, I think, to graph it. Good. So we have a -2. Think about where that would be on the number line compared to 4. 4 is over here, -2 is over here. Good. X is greater than -2. Right? X is less than +4. It's going on forever, right? So if these were by themselves, that would be our answer, like from last week. This would be our answer to this one. But now, because compound means more than one, that means we are putting those two amounts together. So we take the limit here, right? The limit in this direction is not an arrow forever, it's -2. The limit over here It does not go forever in a positive direction. It stops at 4. These are the only parts of the number line where x is greater than -2 and x is less than 4. Okay, and then my graph was from -2 to 4, did not include either of them. So if I just had this as interval notation, I would know to start my graph at -2, to end my graph to end my graph at 4, and to use parentheses. So I always read it from x, okay? -2 is less than x does not make as much sense to me as x is greater than -2. So I like to change them. Here, you're doing the same thing you do for solving a regular equation that's not an inequality. You are doing addition and subtraction first, and then you're doing multiplication and division. So -2x minus 7 means that we're subtracting 7. So we're going to do the opposite. We're going to add 7. I don't need to do anything with my signs because there was no multiplying or dividing by a negative. So the sign stays the same. -9 plus 7 is a -2. There's now just a 2x in the middle. 17 plus 7 is 24 because 7 plus 7 is 14. All right, now I have -2 is less than or equal to 2x, which is less than or equal to 24. Good. Now I'm going to divide everything by 2. If I divide by 2 here, I have x alone. That's what I want, is x alone in the middle. So if I divide it by 2 on this side, I need to divide by a +2 over here, divide by a +2 over here, okay? You do not flip the sign if this is positive. It's okay that these are negative. You only flip the sign if the one you are doing the action with, right? This is the action part. We're doing the action to the original. We're doing the action to the original. So only the action number is negative is the only time we would change it. So these stay the same. 2x divided by 2, we're left with an x. -2 divided by 2, remember, any number divided by itself is 1. So 2 divided by 2 is 1. -2 divided by 2 is a -1. So -2 divided by 2 is a -1, is less than or equal to x, is less than or equal to 24 divided by 2 is 12. Good. Even if, sorry. No. Getting off on a tangent. All right. Even if you were just making a graph, or sorry, making a fraction that said 24 on top, 2 on the bottom, that's still 12, okay? Because all fractions are division. So now x is greater than or equal to 12, and x is less than or equal to -1 at the same time. So here's -1, here's +12. Good. Because of those equal to's, I know that that is going to be a bracket, but I want to make sure x is less than 12. I want to make it, it's easy to assume that it's going to be between these two, but you always want to make sure x is less than 12. Yes, that does go that way. Good. X is greater than -1. Yes, that does go that way. Our answer is bracket -1, 12, close the bracket. Right, example 4. 2 is less than 4 minus x, which is less than 7. I want to get the x alone in the middle, so I'm going to subtract 4, subtract 4, subtract 4. 2 minus 4 is a -2, right? Because 4 minus 2 is 2, but the 4 was a negative. The bigger term is a negative, so you add a negative to your answer, a negative sign to your answer. 7 minus 4 is a +3, right? And then 4 minus 4 eliminates the 4, but we still have a -x. It's very important that that minus sign stays with the x. If you have a subtraction sign, it's always the sign of the term behind it. So now I have -2 is less than -x, which is less than 3. Good. How do I get rid of this negative? Because it's not done yet. I can't say that I solved for -x. You can only solve for +x. So what I need to do is divide by a -1. Any number, like if I have -100 and I want it to be a +100, I can divide by -1. Opposite is true. If it's positive and I divide by -1, it just makes it negative. So it's a way to do a sign change. -x divided by -1, no matter what x is, now becomes a +x. However, 3 divided by -1 becomes a -3. -2 divided by -1 becomes a +2. Just think about it. Negative divided by negative is positive. Negative divided by negative is positive. Positive divided by negative is negative. And because of that negative sign, we're flipping the symbol. Because we divided by negative on this side, we're flipping the symbol. So that means 2 is greater than x, and x is greater than -3. But remember, I don't like it facing that direction, so you can also just flip it. -3 is less than x, and x is less than 2. So x is greater than -3, x is less than 2. Those are the same individual parts I had over here. It's just easier to read them when x is on the left. I have a number line. All right. Here's -3. Here's a +2. X is greater than -3. There were no equal signs, so it's only going to be parentheses. X is greater than -3. And x is less than +2. Open the parentheses. Start at -3. It ends at 2. We close the parentheses. It does not include 2. And then just think about if I saw this as interval notation, what would I write as a graph? I would write this. Oh, sorry. I would write this, which is what I have up here. So that's a good sign. All right, the other half of today that we have 6 minutes to cover is union. Union is the letter U, and it is OR. It's the solution set of a compound inequality formed with OR. It means that anything belonging to either of the sets is included in the union, okay? Everything. So if you were finding the union, do you see this, the difference? AUB is not just this middle part, it's all of it. Everything from A and everything from B at the same time, okay? So the union of this group and this group is this number, this number, this number, this number, which we already wrote down, so we don't need to write it twice. This number, and this number. So everything from both of them without repeating. So just make sure you feel comfortable with the difference between union and intersection, okay? So the union is going to look like that. The intersection of that same group is going to have an upside down U, and it will only include, so we're looking at these same two groups, the intersection of those two groups is only going to include 4 and 6. Those are the terms that repeat. The union is everything. And the union has the letter U. Again, or means it includes all values that make this true or that true. Okay? So if you have or, you're covering everything. You're not eliminating, and you're eliminating part of it, right? Okay. Two minutes. Is that just too stressful? All right. 5 times the quantity x minus 1 is greater than or equal to -5. We're going to take the 5 and multiply it by x, and then we're going to multiply it by -1, so we get -5 greater than or equal to -5. Good. Add 5. Add 5. You end up with 5x greater than or equal to 0, right? Divide by 5. Divide by 5. X is greater than or equal to 0. Good. Five minus x is less than 11. I'm going to subtract 5 this time from both sides. Yes, draw a line for clarity. Now I have -x less than 11 minus 5 is a +6, right? Again, I can't have a -x, so I'm going to divide by -1 on both sides. That means I need to flip the sign. +x is greater than -6, okay? There are no or problems on the homework or the quizzes or the exams. But I guess I could show you how to graph it. We still have a minute. X is greater than or equal to 0. Sorry, I need to label 0. X is greater than or equal to 0, or X is greater than -6. So if this were and, we would only include what overlapped, but because it's or, it includes everything, all of this one and all of this one. So our true answer is and the way it would be written in interval notation would be from -6 to infinity. But again, that's not on the exam. Oh, sorry, it's 51. I apologize.